tag team effort because this has been a large collaboration between people with different specialties, as we tend to do in disease investigations, because you do have to look at them in many different layers, from field work to the molecular level. And today we're going to present some of our findings on a disease that we found, Montipora white syndrome. And this is a disease that causes tissue loss in Montiporas, and this is Montipora capitata, that we have found during our surveys across the Hawaiian archipelago. But we found that it was much more common within Kaneohe Bay, and so we started some focus studies trying to understand this disease a little bit more, trying to figure out the ecology of it. How damaging is this disease? Where is it distributed within Kaneohe Bay? And so we had a lot of objectives, probably a little too ambitious, to look at this disease. And the first 4 of these I've pretty much reported on in detail in the last presentations. So if you don't mind, what I'm going to do is just sort of verbalize those findings for those of you that weren't there. For the first 3, we were looking at the distribution within Kaneohe Bay. So we surveyed reefs in South, Central, and North Kaneohe Bay, and we picked these regions because the differences in both water circulation patterns, so there's much more reduced water circulation here than, say, here, and the amount of anthropogenic stressors that each of these corals receives. So when there is a heavy rainfall, all of us that live on Kaneohe Bay see there is heavy sediment that's really coming out over these reefs here. Here it tends to get washed off much more rapidly. So we surveyed 3 reefs in each of these regions. We also surveyed these in the fall when the water was warmer and in the spring when the water was colder to see if there were any seasonal differences in disease. Because in other areas, such as in the Florida Keys, they have found distinct seasonal differences. Say in black band disease, it shows up in the summer, disappears in the winter. So we wanted to see if any of those patterns were also found here on the Hawaiian reefs. And in a nutshell, what we found was this disease was throughout Kaneohe Bay in all regions, but it was found, much higher levels were found in the South Bay, as we might expect. And somewhat surprisingly, we found no real seasonal differences in disease levels. So that's very different than what other regions are finding. But in Kaneohe Bay, we have sort of a different stressor in each season. In September, we do have the warmer temperatures guaranteed. And some of the times when those Kona winds drop and that sun starts heating up that water, you've also got this UV stress. But what do we have in the winter in Kaneohe Bay? Heavy rains, heavy sedimentation, and so these corals really get stressed by that. So part of it may be that the fluctuations in water temperature in our oceans are not as great as in Florida. But I think some of the other reasons that we might not be seeing this is that the stressors vary. One may be temperature, but the other, that heavy runoff is pretty significant. Also in Kaneohe Bay, we frequently will have sewage spills. So there were a couple times last year when we were supposed to be going out into Kaneohe Bay to conduct our surveys that we weren't allowed to enter the water because it was so dirty. So those are some of the things our poor little corals have to face on that. We also thought that there might be differences between the fringing reefs in the South Bay and the patch reefs in the South Bay because these corals here definitely get hit by the sediment a little more heavily than these. But we didn't find any differences. I found that a little odd. But what that tells me is that there's multi-factors that are going into determining the levels or patterns of disease that we see in the field. As far as number 4, which is the rate of tissue loss from this particular disease and ultimate fate of these colonies that become infected with this disease, in a nutshell, what we found, corals that look like this to start. You can see the areas of multifocal tissue loss. A year later, look like this. So we found we lost about 1/3 of our colonies, roughly. They were pretty much dead from this disease, several which completely collapsed and tumbled down the slope. But the good news was that there were about 20% that had less than 10% tissue loss. They were able to maintain their colony structure even though at some point they caught this disease. Now, this is very different than what we found in a cropper white syndrome in the northwestern Hawaiian Islands. What we found when we tagged individual colonies out there is almost all of them crapped out. There was, I think, one colony that was able to maintain its tissue. So we're seeing a tissue loss disease on two different types of coral in two different regions that have very different outcomes. And the other interesting thing, and you'll, Terry will talk a little more about this, is that along with this pattern of being able to arrest the disease is when we do follow these, we see this disease will start and stop. So we don't know if that's something the coral's doing to stop this disease or an environmental factor so that the balance or the fight between the pathogen and the coral is shifted back and forth or what's going on there. But that's an interesting pattern we're starting to see there. The one thing that we didn't report on last time is we wanted to understand whether this disease was infectious. It appeared to be infectious in the field in that in our individually marked colonies, if this colony was infected and we're following it through time and these chairs were the other colonies around it, we'd come and by month 5 or month 3, this colony right here is now infected. So we're seeing that pattern of spread in the field sort of qualitatively. So what we want to do is bring this into the lab. We get fragments of off colonies that are showing this tissue loss and put them in aquaria closed systems with healthy fragments just to see if that disease is transmitted. And so we'd used an experimental design, affected piece, one piece touching of healthy, one piece not touching, to try to determine whether this is through direct transmission only or perhaps or waterborne transmission of this potentially infectious agent. And then each experimental tank had a paired control tank. This controlled for both water quality, any sort of tank effects that we might have problems with, and the genotypic interactions between two different corals. So this fragment clearly from a diseased piece is from a different colony than the healthy ones. And so we wanted to control for that too to make sure that these two genotypes were not the same. So if they're fighting each other, was that what is causing the disease, actually not an infectiousness? And what we found with this, indeed this is infectious, we found that all of the pieces that were touching all the healthy pieces that touching the infected did experience diffuse tissue loss, so that was our signal that there was disease happening, is there's tissue loss. We did not see this in any of the control tanks at all, and we found that about 50% of the fragments that were in the aquaria but not touching also started experiencing this tissue loss. We did run into, and you can see the time to infection varies from 7 to 35 days. This didn't surprise me too much because we were using different genotypes between pairs of experiments. And what we found is that in the field you'll have differential susceptibility among corals to disease in the first place. And then the study we did with Debbie Gottschfeld in Mississippi looking at the antimicrobial defenses of these corals also found intraspecific variability in the amount of antimicrobial defense produced by these different corals. But we did run into one little problem, and that is this little booger. And this is a little flatworm that likes to eat Montipora. And we weren't using filtered water because we did have the paired control. And in some of the tanks, we did find these little boogers and quickly figured out that they were also eating some of the tissue. So these were found in both control and experimental tanks, and we didn't really see that type of diffuse tissue loss in the control tanks. But just to be sure, actually just yesterday, we set up a whole new round of transmission experiments using the filtered water to keep this booger out. Now, when I was doing my dissertation work, I worked on Porites. And Porites has Fistella, which is a coral-feeding nudibranch that would always come in and crap out our experiments. So I should have known better with this guy.